Hi guys, so far we've talked about different properties like solubility, melting point, etc. And we can separate substances based on those different properties if they're mixtures. So we can separate mixtures based on their different properties. So before we go into the separation of mixtures though, I thought we'd just first have a quick recap on the difference between an element, a compound and a mixture. Take some notes using the following flowchart as a basis. So we've got matter, okay? So chemistry is made up of matter. Matter is really anything that takes up physical space. As you remember, matter is anything that takes up physical space. So that describes anything. But we can then separate matter into two different substances. We can separate it into things that are mixtures and things that are pure substances. And in general, pure substances are things, another definition, pure substances consist of only one type of atom or molecule or formula unit. So what that means is either they only consist of one type of atom, in which case they would be an element, or they consist of one unit that comprises of one type of molecule. A molecule is where you've got a couple of different atoms or the same atom, but they're bonded together in one unit. So for example, water, that's a compound. It's got oxygen and two hydrogens. So that's a pure substance because it's just got oxygen and hydrogen. All right, so it only consists of one type of atom, molecule or formula unit. That's a definition of a pure substance. And then there's two subcategories of pure substances. So we have compounds and then we have elements, as you can see here, compounds and elements. So we've got the compound, which is a substance formed when two or more elements are chemically bonded together, as we've said here. And that, water, again, prime example of that. Two or more elements, so oxygen and hydrogen, chemically bonded together by these bonds. That's a compound. The other type that we have right here is an element. And an element is a pure substance that consists of only one type of atom. And then we've got the other side. So the other side over here is substances that are not pure, so they don't just consist of only one type of atom, molecule, or formula unit, and they're called mixtures. So mixtures consist of two or more materials that are not chemically bonded. So hopefully you're following this diagram through and you can see that we have two types of mixture. We have a homogeneous mixture right here, and we have a heterogeneous mixture. So to be able to work out which is which, we ask this question up here. Is the composition uniform? So does that mean, is the mixture the same composition or have the same properties all the way through? So for example, water, petroleum, alloys, mixtures of metals, you cut them up, you pour them out, they look the same the whole way through. Seawater, sorry, not pure water. So salty water, you've dissolved salt into them. It's not a chemical reaction. It's not a chemical. It's not a compound that's formed. It's just salt dissolved in water. So you've got a mixture happening there, but it's the same composition or same format the whole way through. Whereas something more like a gravel or even blood doesn't necessarily have the same composition the whole way through. So homogeneous mixtures and heterogeneous mixtures, I'll just write the definition of those. Those ones right here, copy them down. So that gives us a little bit of a background, and now we're going to think about mixtures and how we separate mixtures. And because they're made up and not chemically bonded together, that means we can separate them using techniques like distillation, filtration, evaporation, which we will learn about soon.